Hey there kids, welcome to another math lesson. We're in module 3 now, and this is for lesson 3 homework. The objective here is to add fractions with unlike units using the strategy of creating equivalent fractions. It's right there on the bottom of your page. And so since today we're using unlike denominators, we have to make equivalent fractions, and we're going to use a model to do that. In the beginning, after a while, they get super complicated and annoying, and it takes a lot of time, and then we can just use numbers. But right now, we're just trying to tie together the model with the numbers, so pay close attention. Also, you should have already completed your homework. This is just a check, and to figure out what you're doing right and what you're doing wrong. If you don't know how to do this, go watch the problem set video and learn about it first so that you're not going into this kind of blindly, not knowing what you're doing. You should know how to do this from the problem set. So let's get started. We have 1/4 plus 1/3, noticing that the denominators are different. So we're going to draw these two fraction models to represent what each one is. And if you watch the problem set, you know that the first model, I'm going to make that with vertical lines, and I'm always going to draw or shade. I typically do it on the left, 1/4 on the left, plus my second model is going to have horizontal lines, and I'm going to usually shade the top. You could shade the right or the middle or the bottom or the middle. It doesn't really matter which one you shade as long as you're only shading one, because that's what the numerator is telling you to do. Okay, now for your equivalent model, you're going to take the one from the second and put it onto the first. And then you're going to take the model from the first and lay it over the second. So you're making equivalent fractions by using the other denominator to create this picture. So for this first model, I'm going to take my thirds and I'm going to cross, going across my model, and I'm going to take fourths, which I had over here, and I'm going to make the model using those vertical lines. So now I actually have, because fourths over thirds make twelfths, and thirds over fourths make twelfths, we now have twelfths and twelfths. And so that's how we get our common denominator. And we'll talk about this as we lose the models and just use numbers. And so how many then are highlighted? And so that's going to be our new numerator. So here I have 3, and here I have 4. And we only add in fractions. Remember, the bottom, the denominator, is like a label. So we're only adding the top numbers, and then we're just calling it the label of the bottom. So it's 7/12. And that's your final answer. Now we'll talk more in future lessons about simplifying, but that's all for now. 1/4 means 1 out of 4 pieces will be shaded, plus 1/5 means 1 out of 5. Remember to go horizontally on your second model. Now you're going to take your fifths and you're going to lay them across here horizontally, and take fourths and stripe it down vertically. And if you want to count until you're comfortable, I'm making fraction bars and putting my sum or addition sign. 1, 2, 3, 4, 5. Why does it turn into 5? And how many pieces are there now? Well, it's 4 times 5, so it's 20. So basically what we're doing is we're multiplying those two bottom numbers together. And if you really must know, you could take that bottom number that you're multiplying, and that will give you your new numerator. Look, 4 times 1, that's called cross multiplication. That's what your parents used to do. 4 times 1 is 4 on the second fraction, and 3 times 1 would be 3 on the first fraction. Don't get too lost in that. Focus on the models for right now, because I don't want you to put your numbers in the wrong place. So anyway, this one has 4 out of 20. When you add them, you get 9/20. And then we're going to leave that alone for now. And we've got our 1/4. Shade just one of them, plus 1/6. Now I like to divide it in half and then do the top half with 3 and the bottom half with 3. That helps me to have equal sized pieces. You can try that too. And then we're going to take our sixths and again split it in half and then do 3 on the top and 3 on the bottom. And fourths over here would mean half, half the left, half the right. How many pieces are here? And again, you can just count them, or you can look at the multiplication that would give you out of 24 pieces, because 4 times 6 is 24. That's how you can know that you got that. And then I'm going to have 6 over here and 4 over here. When I add them up, I get 10. We're okay with leaving this as 10 24ths. We're going to talk about simplifying in the future, but for right now, you can leave it alone. 1/5, 1, 2, 3, 4, 5, shade 1. Plus 1/9. Now this is going to be a whole bunch of little tiny lines, so in order to organize it, make thirds first, and then do 3 in each section. Because yes, you do have to do that. Okay, so shade 1, super tiny. And then we're going to cross over each one. So I'm going to make 9ths on my 5ths, so 3 sections. And then the thirds again, that's how you get your 9. And 5ths over here. 1, 2, 3, 4, 5. Lots of tiny boxes. Now when you look and see, well, how many do I have? I tell students, do not count by ones. Some students will be like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And eventually they'll get something like 51. And I'm like, no, it's not going to make 51. Remember, check with multiplication. Okay? Because a lot of kids will just miscount. If you want to count by anything, either count by 5s or count by 9s. 1, 2, 3, 4, 5. Then you can go down 5, 10, 15, 20, and so on. If you want to count by 9s, it would be 1, 2, 3, 4, 5, 6, 7, 8, 9, and you should get 9 because it's right there. And then you could do your 9, 18, 27, and so on. Okay? So, also, using that cross multiplication can help you know how many are shaded in your new model and how many are shaded over here in your new model. Oops. It looks like a 9. And I'm always telling my students, make your 4s nice and neat so that I can tell it's a 4, not a 9. Keep it open. Okay, so I know you'll probably have questions about simplifying this, but for today, my bad. Simplify your answer if possible. Okay, so for your simplified answer, we're going to take our 10 24ths. And we're going to look for ways to simplify and divide because you can. The others you can't, so we're okay leaving those. But today on C, 10 24ths can be simplified. How do I know it can be simplified? Because you divide by a number that you can count to evenly and that will go into both. So I'm going to use, say, a 2. Because I can skip count by 2 and get 10, and I can skip count by 2 and get 24. So when working with fractions, I have it all in all my other videos. We're going to keep the ratio the same from the top to the bottom. So when simplifying, you've got to have the same number on the top and the bottom. That means this fraction is equal to 1. And any number divided by 1 equals itself. So this is just itself looking different. So it's going to be 5/12. Oh, there's a flag. Ew. Okay, 5/12. And that's the simplest form. And so we're going to leave that one there. This is nice, but this is better. And that's what the directions said, so you want to have that one. All right, turn the page. Got a couple more where we just get to make the models. 1, 2, 3, 4, plus 2/5. 1, 2, 3, 4, 5. Shade 2 of them. Okay, and then lay over. Now notice that on the previous page we only had 1s as our numerators, and now we have 2, so you're going to have 2 sections shaded. But you're going to do the same thing to make your equivalents. You should have 5ths now laid over the top and 4ths vertically here. Now that's going to change how many you have because we're going to have more. It's going to be more than just the denominator. So how many pieces did you make? You're going to have 4 times 5 for 20. And then because there's only one, if 5 times 1, that's 5. 1, 2, 3, 4, 5. Do the double check. And then this is 4 times 2 because it's 2 of them that are shaded. So yeah, it is 8. See, 4 plus 4 is 8. When you add these up, we don't have anything that can be simplified because 13 is a prime number. So that's going to be one of the things that you look for. I probably haven't talked to you much about prime numbers. We'll get to that a little bit later. But if it's both even, you can simplify it. If they're, you count by 5 for both of them, then you could divide by 5. Oh my gosh, this fly. How often? Okay, moving right along. Happy camper. Okay. I have a fly swatter here, but you guys would be grossed out if I smashed the fly. That'd be great. Okay. 1, 2, 3, 4, 5. And this time we're going to shade 3. So 1, 2, 3. When the flies are all aggressive in the fall. Ugh, ugh. Oh my gosh. 7 this time. 1, 2, 3. 4 should be a little bit past the halfway. 4, 5, 6, 7. And we need 3 shaded on this one. So 1, 2, 3. Oh my gosh. So gross. Okay. Now lay over your 7ths and lay over your 5ths. 1, 3, 4, 5, 6, 7. And 5ths. 1, 2, 3, 4, 5. Look at my lines are all wiggly, but again, not art class, just math class. 7 times 5 means that we have 35 pieces in each model. And so how many are shaded here? Okay, it's 7 times 3 for 21. It's 7 and 7 and 7. You can count them if you want, but it's really easier to just do 7 times 3. And then you can count here, 5 times 3 is 15, 5, 10, 15. Add those up. If you have double digit, you can still add horizontally and just do the ones place. That's the one on the right. 5 plus 1 is 6, and 2 plus 1 is 3. Or you can just add them together. Now what happens when I have this big, giant 36 35ths? That means I have a number that's bigger on the top. It means that if I was to move all these shaded pieces over here and fill them in, I would not only fill in the entire model here, but I would have an extra. So what this is it's one whole model plus one extra of the 35ths. And so this is equal to this. They're equal. So that's just a different way of writing it. So this is called the simplified version. All right, this time I'm going to read the directions. Solve the following problems. Draw a picture, that's the fraction model, and write the number sentence that proves the answer. Simplify your answer if possible. Mrs. Zetness, do that. Okay. Rajesh jogged 3/4 of a mile and then walked 1/6 mile to cool down. How far did he travel? That's a lot of walking. Put them together. When we have different denominators in the beginning, you can make this model. It's 3/4 that are shaded on this one, and 1/6. Remember to divide it in half if you can, if you have a lot of pieces, and shade 1. When they say shade, I usually just stripe it. Obviously, I've been doing that the whole time. Just make it so that it stands out. Okay, now we need to have common denominators. So since the approach this time has been to lay over, I'm going to go ahead and do that, even though there's a simpler way of doing this. But since we're just learning, I will save that for after I've solved this, okay? So I've got my 6th on my 4ths and the 4ths on the 6th, and now I can have my 24ths. And see that I have 18 here. It's 6 3 times. And then I have 4 1 time for 4. And when I add them together, I get 22 24ths. Now, earlier I was talking to you guys about if they're both even, you can simplify by dividing by, if nothing else, 2. But what you do to the top, you do to the bottom. If I'm going to divide the top by 2, I must divide the bottom by 2. It has to stay the same, so I would get 11/12. Now, another way that you can do this, I want to show you real quick. Since 4 and 6 have a lower common denominator, I don't have to use 24. Some of you guys might say, well, you could use 12, and I'll show you how to do that. So if you skip count, these are what times 1 would give you, okay? So if I do times 2, I'm going to get 8. Times 2 will give me 12. Times 3 will give me 12. And once you see that you have something in common, this is called a common denominator. And so instead of using 24ths, I could use 12ths. So back when in old school land, okay, we used to set things up vertically so that you could see what you were creating. You could say, well, I want to make 12ths out of these. So how do I get from 6 to 12? It's a scale factor of 2. Scale factor is probably in one of my other videos. You should know what that is. It's the factor that you're scaling up by when you multiply. So 6 times 2, therefore 1 times 2 is 2. The scale factor for 4 is different because it's a different number. So 4 times 3 is 12, therefore 3 times 3 is 9. If I was to add 9/12 plus 2/12, I would get the 11/12. And so this is the same as what I get here, but you can go about it a little bit differently using smaller numbers the whole time. These are bigger numbers. That means more room for error, okay? So next one, let's move on. Cynthia completed 2/3 of the items on her to-do list in the morning and finished 1/8 of the items during her lunch break. So what fraction of her to-do list is finished by the end of her lunch break? So it's this and this together. The extension will do that in a second. What fraction of her to-do list does she still have to do after lunch? Really important concept here. Take your 2/3 and 1/8. We need a common denominator. You don't have to make a picture. I don't believe, no, I think it did in the directions. It says make a model. And 1/8, I'm just doing it to help everybody understand. If the top is going to be 4, then you can go halfway, halfway, again half, half, half. This is super tiny, but I'm going to shade it anyway, and the lights went out, so we make them go on. I wonder if I leave the lights out, if the fly will stop bothering me. Okay, and then we're going to do 1/8 over this, 4ths, and then 1/8 and 1/3. Now if I have 3 times 8 making 24 pieces on each one, then 8 times 2 would show me 16 pieces over here, and 3 times 1 would give me 3 pieces over here. Double check again. Then we're going to combine 16 and 3 make 19 24ths. So what fraction of her to-do list is finished by the end of her lunch break? 19 24ths is finished by the end of lunch. So what do we do now? Well, the whole equals 24 24ths, which equals 1, which equals the whole. So this fraction has everything done. So if she's only part of the way done, then in order to find out what's left, you find the difference between the two, okay? And this will change. It can change because we don't know how many parts are going to be in a different word problem. So you'll see in number 4. But this 24 over 24, that means the whole thing, the whole activity, the whole drive, the whole whatever. So it's whatever number of parts we have. So the difference here is that 5 24ths are left for later, or she still has to do after lunch. Okay, so there you go. So you have your 2 answers because there are 2 questions. This is the extension. Okay, hope Hope that helps. Here is another one that will help solidify your understanding. Oh yeah, click subscribe if you're not a subscriber. Be one. It's cool. Sam read 2/5 of her book over the weekend and 1/6 of it on Monday. What fraction of the book has she read? What fraction of the book is left? So we're going to talk about the whole. 2/5 and 1/6. So make a picture. 1, 2, 3, 4, 5, and 2 of them are shaded. And 1/6, half on top, and then make 3, because 3 plus 3 makes 6. 1 is shaded. Once it's shaded, then you can cross over and make your 6ths here. 3 on top, 3 on the bottom. Once it's shaded, you can make your 5ths here. 1, 2, 3, 4, 5. Okay? Now we've got our equivalent fractions. 5ths and 6ths would make 30ths. Multiply or look and count and double check. 6 times 2 makes 12 on this model. Don't put 12 over here. That's not reflective of that model. 5 is over here. Keep the equivalent fractions in the same space. That kind of drives me crazy when I'm working with the kiddos. I'm like, it's all mixed up. Doesn't that drive you crazy? Add these up. Okay, and so this is what she has read already. She read it already, okay? But there's more. But wait, there's more. What fraction of the book is left? So now, think about what I just told you, and think about what the whole book represents. What would be the fraction be? Well, it's going to be 30/30ths, because that's our common denominator. We just figured that out. So take the whole book and find the difference between that and what she already read. And the difference would be 13, because 17 to 27 is 10, and 3 more. And 30ths is just the label. So 13/30ths is left. Yay. So that's about it for today. I hope this is helpful. I hope you are starting to understand your fractions. It's a fun module, but lots to know. Hopefully we'll see you on the next video. Bye for now.